Evaluate integral from 0 to 2 y to the power 4 to bracket 8 minus y to the power 3 all to the power minus 1 on 3 dy. So we are still on beta functions. And we know our aim is to express the whole problem into this form so that you can apply the general definition for beta functions. And this is the general definition for beta function. So our aim is to make the term in the bracket of the form 1 minus x to the power something and this that. So to do so, let's rewrite this problem before we do the substitution, because the term here is not 1. We have to do so that we get a term here 1, right? And followed by the corresponding substitution. So here let's rewrite the question. Integral from 0 to 2 y to the power 3. Let's leave it at the power 4. Now let's leave it as such. So let's bring 8 out. Like I said earlier, 8 out. And don't forget the power. The power also have an effect on 8, which is minus 1 on 3, all into brackets. When a is out, forget about the power now. So 1 minus 3 all to the power. So when you bring 8 out, now all of these they have, a power to a power of 1 minus 1 on 3. Minus 1 on 3. So when you multiply 8 by 1, you get 8. When you multiply 8 by y to the power 3, you are not getting y to the power 3, you are getting 8y to the power 3. So to solve that problem, divide this place by 8. So if you multiply 8 by this, 8 will cancel out, remaining y to the power 3. So here, dy. So now we are going to do our substitution. So we substitute this with a term. So let's do that with u. So u equal y to the power 3, not negative, because we need a negative sign there. So now u equal y to the power 3 on 8. So let's make y the subject, because we will be needing the value for y, the value for dy, so that we will complete our substitution. So multiplying through by 8, we are going to get 8u equal y cubed. Y cubed, then let's take cube root to both sides. Taking cube root to both sides, this will take care of that. And we have y equal cube root of 8 will give us 2. And cube root of u is the same as 1 on 3, right? Because if we have u squared is the same as u to the power 1 on 2. So u5 is the same as u to the power 1 on 5, right? So now we know the value for y. So what we also need is dy. So dy, we know our y equal, let's keep this in mind and this in mind. Our y equal 2 u to the power 1 on 3. So dy is going to give us, we are multiplying everything by the power of u. So 2 multiplied by 1 on 3, u to the power 1 on 3 minus 1, the power decreased by 1. Then du. So simplifying this, 2 by 1 on 3 will give us 2 on 3. And 1 minus 3, 1 on 3 minus 1 is going to give us an exponent of u to the power minus 2 on 3 du. So this is our dy. So with this, we now check our limit. We said our u equal y to the power 3 on 8. So now set our limit. So when y equals 0, what is the value for u? So on y equals 0, we are going to get 0 cubed on 8, which implies that u equals 0. When y equals 2, what will be the value for u? So we are going to get 2 to the power 3 all on 8, and this will give us 1. So 2 to the power 3, 8. 8 on 8 gives us 1. So now we can go ahead and make our corresponding substitution. So we have integral. Now our limit is from 0 to 1, which is what one of the things we are expecting. Because to use beta functions, our limit is supposed to be from 0 to 1. Integral from 0 to 1. So now we have integral from 0 to 1, y to the power 4. And we said y equal 2u to the power 1 on 3. So we are going to substitute by that. So 2u to the power 1 on 3, all to the power 4 right here. So all to the power 4. And we have a to the power minus 1 on 3. I think this is actually going to affect my work here. So a to the power minus 1 on 3. Let me write this again. So we have integral from 0 to 1. We have y to the power 4. And y to the power 4, we said that y is 2u to the power 1 on 3. So 2u to the power 1 on 3, all to the power 4. And we have a to the power minus 1 on 3. Then followed by 1 minus. We said our u should be y to the power 3 on 8. So here will be u all to the power minus 1 on 3. And our dy, what is the value for dy? We solve for dy here to be 2 on 3 u to the power. So 2 on 3 u to the power minus 2 on 3 du. So now we are going to simplify this. So we have a constant here. This is actually a constant. This is also a constant. So before that, integral from 0 to 1, 2 all to the power 4. So this will give us 2 to the power 4. And u raised to the power 1 on 3 by 4. So u to the power 1 on 3 by 4 is simply u to the power 4 on 3. And a to the power minus 1 on 3 here. Let's bring this constant here, which is 2 on 3. Then at the end of the day, we can bring our bracket minus 1 on u all to the power minus 1 on 3. Then our u here, u to the power minus 2 on 3 du. So bringing our constant out, we have 2 on 3 and 2 power 4 and a to the power minus 1 on 3. And yeah, I think that's all for our constant. Integral from 0 to 1, u to the power 4 on 3 and u to the power minus 2 on 3 into bracket 1 minus u to the power 1 on 3, minus 1 on 3 du. So simplifying, because these terms here has the same basis, because they have the same basis, we can just add the power. So 4 on 3 minus 2 and plus 2 on 3, which is same as minus 2 on 3 because of the negative sign. So this is going to give us, and we know before that, we know that 2 to the power 4 is 16 and 8 to the power minus 1 on 3 is half, and we have 2 on 3 there. So simplifying this will give us 16 on 3. So 16 on 3, integral from 0 to 1. This one right here is going to give us u to the power 2 on 3, all into bracket 1 minus u all to the power minus 1 on 3 du. So now, at this point, we can compare to our general definition for beta functions. So we see beta of mn should give us this. So comparing, we now have 1 here, 1 here, minus x minus u, which is like generally of the same form. So we can now equate powers and look for our m and also look for our n. So equating the exponent of 1 minus x term, so we have n minus 1 equal minus 1 on 3. And to solve for n, let's multiply through by 3. So 3n 3 equal minus 1 crossing give us 2. So n equal gamma n all over gamma m plus n. So 16 on 3, beta of 5 on 3, 2 on 3. So give us 16 on 3, gamma 5 on 3. I'm sorry, this is not comma. Gamma 2 on 3, or on gamma 5 on 3 plus 2 on 3. So this will give us 16 on 3. Gamma 5 on 3. How can we simplify gamma 5 on 3? Or how do we simplify gamma 5 on 3? So we are trying to express this in the form of, now let's keep 16 on 3 aside for now. So if we have gamma of n plus 1, it should be equal to n gamma n, that is for fractions. So we are trying to look for a value that if we add 1 to give us 5 on 3, that is if we are finding for gamma, if we are solving for gamma 5 on 3. So n plus 1 so give me something, gamma 5 on 3. So I don't know that, so I just equate n plus 1 to 5 on 3. So n plus 1 on 5 on 3. So solving this, we get our n to be 2 on 3. So looking at this, I can therefore go ahead and say my gamma 5 on 3, my gamma 5 on 3 is equal to 5 on 3 gamma n. I actually have videos on this. You can check them out to gamma 5 on 3. So we are going to do this on up to a point where if we are going further, we get a negative number, then we stop, or we get a constant which is half and it is square root of pi. But I have a way of simplifying expressions of this form. So let me just show you that. Let me show you that. So when we solve for gamma 5 on 3, we got 5 on 3, gamma 5 on 3. So to shorten this video, so we are going to find gamma 5 on 3, right? So just write 5 on 3. Just type 5 on 3 on your calculator. Subtract 1 from it. Whatever you get, you write that one. So it's 2 on 3. Dot. Subtract 1 from it again. Like continue subtracting 1 from it. See, if you continue to subtract 1 from it, you are going to get a negative value. So getting a negative value means that you should stop at that 2 on 3, right? So add gamma 2 on 3. So let's do the same for gamma 2 on 3. Gamma 2 on 3. Subtract 1 from it. You see, you are getting negative number, so just leave it as such. So you already have gamma 2 on 3 there. So multiplying gamma 2 on 3. I hope you are not confused. We are trying to simplify this, and I was trying to solve it one after the other, but I think it will take my time. But definitely, that's how I explain it here. We are looking for a certain number that you add 1 to it, that will give you 5 on 3. When you got that, then you know that when you get that, then you know that, like as we got n here, it means that 2 on 3 plus 1, gamma 2 on 3 plus 1, which is the same as 2 on 3 gamma 2 on 3. Because you are able to express it in this form, just go ahead. So now we are done with the numerator, right? So let's go for gamma 5 on 3 plus 2 on 3. So 5 on 3 plus 2 on 3 is going to give us gamma, let me see, 5 on 3 plus 2 on 3 going to give us 7 on 3. So gamma 7 on 3. Let's evaluate gamma 7 on 3 here by using our method. So what I said is type 7 on 3 on your calculator. Start subtracting 1 from it. What you get, 4 on 3. So 4 on 3 multiplying minus 1 again. Get 1 on 3, subtract 1 again. Continue subtracting 1 up to a point that you get your first negative number or a half. So since we are getting negative number, we'll just stop there. So where did we stop? Our last point is 1 on 3, so gamma 1 on 3. So now simplifying this further, we are simplifying this expression, right? So this will give us, we have gamma 2 on 3, gamma 2 on 2, gamma 2 on 3 squared. So we have 2 on 3 multiplying gamma 2 on 3 squared. And here 4 on 3 by 1 on 3 is going to give us 4 on 9 gamma 1 on 3. So according to basic mathematics, we have two fractions and they are dividing. So this top one here has the right to cancel what is at top here, and this at the bottom here also has the right to cancel what is at the bottom here. So 2 here 1, 2 here 2, 3 here 1, 3 here 3. So we are left with 2 over 3 here, right? So we are left with gamma 2 on 3 squared all over 2 on 3 gamma 1 on 3. Hope you can see that. So we've simplified all of this up to a point where we got, then let's bring out 16 gamma 2 on 3 all squared all over 2 on 3 gamma 1 on 3. And according to basic math too, this 2 here at the top here has the right to cancel this here. So we have 2 here 1, 2 here 8, 3 here 1, 3 here 1. So at the end of the day we get 8 multiplying, this is gamma 2 on 3 all squared all over gamma 1 on 3. So this will be our final answer for this problem. Thank you for watching.